It is my honor to now introduce to you one of the key leaders and champions for the Space Apps program, Dr. Karen St. Germain. She's the director of the Earth Science Division at NASA headquarters. Dr. St. Germain has led NASA Earth Science Division for almost 2 years now. Through her leadership and efforts, our division has made major advances in key principles that I think strike at the heart of the Space App mission. This includes strengthening our commitment to open sharing of data, software, and knowledge, building relationships with private partners that expand the reach and impact of our work, allowing synergistic science and applications achieving results greater than the sum of our parts, supporting the recruitment of the next generation of Earth scientists, and making concrete steps to ensure the US science community and the global Earth science community reflects the faces of our planet. And then also guaranteeing that NASA remains the premier global Earth observing space agency, providing global standards, technology, and measurements to view our planet as a whole interacting system. So I would just want to note that after Karen finishes her presentation, we will have some time for questions and answers. So please post your questions about Earth science into the chat. So with that said, thank you, Karen, for finding time to share with the Space Apps community an exclusive look at the future of Earth science at NASA. Please take it away, Karen.
Great, thank you so much, Keith. And at the bottom of the slide it says, any other fun, cool fact you might want to highlight. I'm pretty sure we didn't mean to have that on the slide, but I'm gonna do it anyway. The fun, cool fact I want to highlight is I have the best job in the world. And it's in part because I get to do events like this one, to meet people like the teams we're meeting today. So with that, I just want to thank, well, Sarah and the team and Keith and the local leads and the space agency partners, but also I'd like to thank all of the winners who just shared their stories with us today. As Keith mentioned, you cannot hear these stories without being inspired by them and optimistic for the future of science. So, you are a very impressive group. Your solutions rose to the top among thousands of submissions, and that's because of your creativity, your teamwork, your perseverance. And I'm also really proud to see how many countries, genders, ages are represented among the Space Apps participants and winners. We have teams of family members, teams of friends, and even teams made up of people who didn't know one another prior to Space Apps, but they found one another through the Space Apps challenge and worked together to be successful, make a submission, and maybe more importantly, formed really strong bonds along the way as they worked toward a shared goal. So, we find here at NASA that we get better results when we bring together people of a variety of backgrounds and invite all to contribute. So I just love seeing that play out in the Space Apps community as well. A special thanks to the 9 space agency partners who joined NASA in making the 2021 Space Apps Challenge such an enormous success. Together with NASA, you represent the power of 10, and which was a theme of last year's Space Apps Challenge, and it was meant to highlight the global nature of the program and celebrate the 10th year. So with that, I'm just going to take a few minutes to show you the exciting things that are ahead in NASA Earth Science and tell you a little bit about what we do, and maybe inspire you as you've inspired me this morning. So with that, could we bring up the slide deck? Thanks so much. So I'm just going to start taking a minute to talk about the end-to-end scope of what NASA Earth Science does. This is a unique program, I think, in the world where we have under one leadership team the end-to-end process of getting to impactful Earth science. it starts with developing the technologies we need to do the science we want to do. That sometimes means inventing new sensors, new components, and doing demonstrations in CubeSats and that sort of thing. We fly missions that make observations of the Earth system and all its components. And I'll show you that fleet in just a minute. But we build and launch many missions a year. We use the data from those observations, those systems, to do basic research and analysis to understand what the data are telling us. Of course, it requires a lot of data infrastructure and compute power to do that. And then we also take that science and try to unleash the power of it through a dedicated effort in applications and applied science. I'll talk a little bit more about each of these elements, but they fit together in an end-to-end way, we think, to deliver really impactful Earth science. So this is the fleet of Earth observing satellites that are flying today as part of the overall NASA science fleet. Each symbol on this chart represents a mission that's looking down at Earth and making observations. Some of them are free-flying satellites, some of them are payloads on the space station, and some of them are CubeSats. So everything in blue and green is a mission that's up there and flying today. Blue means it's living longer than we even thought it might. Green are missions that are still in their prime planned life. And then all the other missions in orange and gold, those are missions that we're building and we'll launch them in the coming years. So it's a really vibrant program, and you can't tell from this slide, but each one of these missions is looking at some different aspect of the Earth system. This is the set of missions that are coming up just this year, and they range from missions that are looking at the atmosphere and tropical cyclones like tropics, to missions like SWAT, which will be able to see inland water in rivers and lakes and reservoirs around the world, and at the same time give us an unprecedented view, a detailed view of our oceans. I think the SWAT mission is going to revolutionize physical oceanography. And missions like TEMPO will look at pollution in our atmosphere, while EMIT is looking at dust, mineral dust in the atmosphere, and how that interacts with clouds and so forth. So we have an exciting set of launches that are coming up this year that will give us even more data. By this time next year, we'll have even more understanding about our Earth system. So I just talked about what's coming up in the coming year. Now I'm going to take just a minute to talk about the major missions that we're building that will launch later in this decade. We call this the Earth System Observatory because it's a collection of missions, but they're all going to work together as though they're a single observatory and give us this 3D holistic view of our Earth system. We'll have instruments that are looking specifically at clouds and precipitation and the atmosphere and aerosols and the interplay between aerosols and clouds. We'll have a system that can see major shifts in mass of the Earth, things like melting glaciers and depleting aquifers, for example. We'll have a surface biology and geology mission that will look at changes in the Earth's ecosystem, the surface ecosystem, and health of vegetation around the world. And then finally, surface deformation and change. That's looking at things like erosion and other major shifts in the land surface. So we're hard at work starting to build these missions to launch later this year, later this decade, and we think this is going to give us an unprecedented view. We'll have another layer of missions around that core that will be, these will be our competed missions, and they'll be looking at other specialized observation areas, such as the ones you see here. We'll competitively select 3 out of the 7 possible observations that you see on this slide, and we'll be starting this program this year. We're very excited about this one. And then I want to just take another minute to talk to you about what we do with all of those, all of the data from these systems. So I mentioned the research and analysis part of the program, and this gives you a sense of the different scientific disciplines that we invest in here at NASA to advance the fundamental understanding of weather, the Earth's interior, climate variability, and how we think that's going to change in the future. The carbon cycle, of course, that's closely related to climate change. And atmospheric composition, that's everything from greenhouse gases to pollutants, to air quality, and the water and energy cycle. So this is a holistic program that seeks to extract that scientific understanding from the observations. And then, of course, we press that scientific understanding into action through our applied sciences program. Applied sciences is organized a little differently. It's not so much organized by traditional scientific discipline as it is organized by how the information could be used. For example, addressing agriculture challenges, which would draw from the weather and also the biodiversity and the surface related missions, as well as the mass change, which can tell us how aquifers are doing. So we organize the applied sciences in terms around themes where we think our Earth observations and our scientific understanding can really help make people make decisions and put science into action for people's lives and livelihoods. Let's go to the next slide. And finally, all of that rests on the ability to get data and information out to folks like you who can do awesome creative things with it. So we're really pushing forward on what we call open source science, which is not just making the data available, but also making our science available as we're doing it, making our source code available, and sharing our workflows and all of the things that allow people to engage much earlier in our scientific process. So we're kicking off an intensive 5-year effort to dramatically open up the science that we do. And with that, I hope we have some time for a few questions. And I guess in closing, I'll just say this. We all know, you all know, our global community is facing significant challenges. And I think science and technology give us the power to do something, to face those challenges. I think science gives us hope. And there's so many new discoveries yet to be made. And I hope you all will be among the people to contribute to those broader solutions. I expect a lot of great things from this community, and I really look forward to following all of your successes. So on behalf of the entire NASA family, thank you so much for engaging in the Space Apps Challenge and working with our space agency data. We love nothing more than to see it being put to use, and finding and working with one another to find solutions that make our world a better place. So with that, I will stop. Thank you.
Thank you so much, Karen. Our first question from the group is from our Datanaut, Karen, in Canada. And she would like to know, one of the challenges in open data is helping eventual users understand its metadata, meaning, context, constraints. And Karen wonders how NASA is helping the public understand all this data.
So it's a great question, and that's a fundamental part of the open source science initiative, which is it's not just about the data itself. It's about also equipping people with the tools, whether that's software or the documentation, or workflows captured in Jupyter Notebooks, the kinds of tools that can allow people to become what we call scientifically productive as quickly as possible. And, look, I don't want to date myself, but let's just say I was in graduate school a while ago. And back then it could take a year to figure out who had the data, get the data, and then write all the code to figure out how to use it. That's a lot of time wasted. So really, the Open Source Science Initiative is about trying to create an ecosystem where we can take advantage of one another's learning and the tools that one another have developed, so that we don't have duplication of that kind of effort all across the enterprise.
Thanks, Karen. Our next question is kind of about that slide that you had shown with the various missions. And it looks like there are many exciting missions on the horizon to be launched by NASA to study our planet in the coming years. So the question for you is, which one of them are you most excited about? And if you can't pick one, what are some of your favorites and why?
Yeah, so I think the one that I'm really, so look, I'm always excited about our missions, and I mentioned that I have the best job in all of government, and I think in the world, and I believe that's true. But one of the great things is going to these launches. In the coming year, I am really excited about all of our missions for a number of different reasons. But the one I'll highlight is the one that I mentioned, SWOT, because I think it's going to be revolutionary in terms of the understanding it gives us of our oceans. And of course, our Earth is a water planet, right? We're 70% covered by oceans. SWOT is going to give us a very different, detailed understanding of the physical oceanography. And it's going to do, so that alone would be enough. But SWOT is also going to allow us to, for the first time ever, inventory the world's surface waters. And as you all know, knowing how much water we have and where it is an incredibly important advance. So that's the one I'll highlight, but boy, it's tough to pick.
Thanks, Karen. Our next question comes from Alvi Ronak, and they ask, does NASA focus on operational and industrial manufacturing data sets in open source data? And which is a potential mine for usable data, especially in third world countries who are the prime manufacturers and global suppliers? So the question is, does NASA focus on operational and industrial manufacturing data sets?
NASA focuses on doing science with any data sets that are available to us, and we hope through the open source science we'll be able to make more data more broadly available. We also do buy data from commercial providers and make that available to our research community. So, and then one other thing that we do is we often try to transition our technology, NASA developed technology, out into the private sector to enable much broader use. So there's a lot of interplay between NASA and the commercial sector in many, many ways. And we think that makes both of us better.
Fabulous. And our next question is about a very special day that we have coming up this week, Earth Day. And so we wonder if there are any ways that NASA is celebrating Earth Day, and if you have any ways that you celebrate Earth Day, Karen.
Well, as you might imagine, in this job, Earth Day is a pretty busy day for me. So NASA has actually the NASA Earth Day website is already live. And we could probably put the link in the chat there. We have a number of Earth Day events. We'll be talking on media outlets throughout the week, and just trying to help people see our home planet the way we see our home planet, in all of its beauty and all of its nuances, and with all of its challenges. There have been millions of decisions that have led to the situation that we see now, which is significant and measurable climate change and associated distributed effects around the world, right? Nobody experiences climate change as a global average increase in temperature of a couple of degrees. We experience climate change in increased drought in some areas, increased precipitation in other areas, increased storm activity, sea level rise that is causing just sunny day flooding in some of our coastal communities around the world. And so we're talking with folks around our country and around the world, trying to help them see the whole earth as we do and engage them to make better, different decisions moving forward, right? I started this answer by saying it's been millions of decisions that have gotten us to this point. It will be millions of decisions that have to be made to address these challenges. And the only way we get there is if we share in the understanding and frankly, the urgency of the situation. So we have a lot of engagement designed to share our view of the world as we see it and invite people to engage. Thanks.
That's wonderful, Karen. Okay, last question before we go and move on to our next speaker for you. Do you have any final words of advice to our global winners and to the broader Space Apps community as they think about pursuing their hackathon journey after last year's event is now behind us?
So I feel like I am learning from this group of people about their passion and what brings them to Space Apps. And so honestly, I feel like I'm gaining more from this interchange than I can share with you all, but I'll try. So I think share your passion, tell your stories. It's great to tell your stories to one another and to those of us who are already in the community, but tell your stories to those in your circles, your family, your friends, your neighbors, your fellow students, wherever you are, and invite others into the enterprise. Because I think this is the story of how Space Apps is doing great work around the world is a great one to share, and it may be an inspiration to others in your lives. So tell your stories. It's never been more important or urgent to do so. Thanks.